Hello friends, welcome to Learner's Planet. Friends, this is our third session for area and volume. In the previous session, we have discussed about the area and volume of some 2D and 3D shapes. Okay, in this session, we will be taking the remaining 3D shapes like cylinder, cones and spheres as well. So let's begin the session. Now, let's discuss about a cylinder. Okay, so here you can see cylinders. This is the circular edge of a cylinder. This is also a circular edge of a cylinder. Okay, now if it is circular, definitely there will be a center, and the distance from center to the edge will be radius of the cylinder. Okay, so this is radius r, this is also radius r. Okay, and the distance from top center to bottom center will be height of the cylinder. Okay, now basically how a cylinder is formed. I show a rectangle over here. You can see this rectangle. If you roll this rectangle, you'll be getting this shape. Okay, so this is how we get a cylinder. If we roll a rectangular shape, we will be getting a cylinder. So this way we can even find out the area of a cylinder also. Okay, now there are two types of, or maybe you can say three types of areas for a cylinder. Now suppose this is a rectangle. If I roll it, I'll be getting a cylinder, but that will be a hollow cylinder. Hollow cylinder means you can see through. Okay, so how do we calculate the area of a hollow cylinder? See, this is the length and this is the breadth of a rectangular. Okay, of a rectangle. Now this length is, if you roll this rectangle, this length will be converted to a circular disc, isn't it? Circular shape. So this L is nothing but 2 pi r. Okay, what is circumference of a circle? That is 2 pi r, and this breadth is converted to height of the cylinder. If you roll it, this is the circular shape and this is the height of the cylinder. So it's 2 pi r and breadth is converted to height. So area of hollow cylinder will be 2 pi r into h. We can compare it with the area of rectangle, that is length into breadth. Now the next thing is here we talked about hollow cylinder. Now what if the cylinder is closed from one side? Suppose the bottom of the cylinder is closed. Now what will be the area of the bottom? Since the bottom is a circular shape, the area of a circle will be pi r square. So one side closed cylinder. It's the area of the curved surface. We hollow cylinder, we can say it's a curved surface also. I just write it over here. So if the cylinder is closed from one side, the total area will be area of that circle plus area of the curved surface. Now area of the curved surface is 2 pi r h and area of circle is pi r square. Okay. Now if the cylinder is closed from both the sides, then there will be two circles. So in all it will be 2 pi r h plus pi r square plus pi r square, that is two circle, one bottom and one top. So it's 2 pi r square. Okay. So we call it as a total surface area. So that is, if I take 2 pi r as common, I'll be getting h plus r. So that is the formula for total surface area. And there are three types of area, as I have already told you. So according to the question, we just have to choose the right relationship, whether this will be the relationship or this will be or this will be. Okay. So the next thing is the volume of a cylinder. Wait a moment. Now, volume of cylinder is further base area into height. Okay. Volume is equal to base area into height. Now in this case the base is circular, so the base area will be area of circle, that is pi r square, and height is, I assume it to be h, so volume of cylinder will be pi r square h, and it will be in cubic units. Okay, so we discussed about area, different areas and volume of a cylinder. Now let's take the other shape. Friends, let's now discuss about a cone. You can see various cones over here. Suppose this is the center. Okay, you can see a circular part over here, and this is the center of this circle. So this is the center and this is the circumference of the circle, or we can say edge of the circular part. So it's r is the radius of the circle, that is the distance between these 2 points. Okay, so radius, and this is height of the cone. Okay, now this is what is the slant height of this cone. This is L. Now this angle is of 90 degree. So this OP and suppose this is Q, they form a right angle triangle. Okay, so if they are forming a right angle triangle, we can use the relationship among R, H and L as R square plus H square is equal to L square. That is the according to the Pythagoras theorem. So R square plus H square is equal to L square, where L is the slant height of the cone. Okay. Now next thing is the area of a cone. So area is further, there are two types of area. One is lateral surface, or we can say curved surface area. So curved surface area will be pi r L, where r is radius and L is this slant height. Now what is total surface area? That is curved surface area plus area of this circular shape. So what is the area of the circle? That is pi r square. So total surface area will be pi r L plus pi r square. Okay. Now what will be the volume? That is 1 upon 3 pi r square h. Okay, so volume of a cone is 1/3 of pi r square h. Okay, so I hope you are clear. Friends, let's now discuss about a sphere. You can see a shape of sphere over here. It's a 3D figure. The cricket ball, the tennis ball, various types of balls are actually spherical in shapes. Okay, so further there are two things. One is the total surface area of a sphere and the volume of a sphere. So total surface area of a sphere, I just mention it over here, is 4 pi r square. Okay, that is the total surface area of a sphere. Now the volume of a sphere is 4 upon 3 pi r cube, where r is the radius of the sphere. Okay, you just have to memorize this formula. Okay, now the other thing is hemisphere. Now you can see hemisphere over here. This is the complete sphere and this is hemisphere, that is half of a sphere. Okay, now if we talk about the volume of a hemisphere, that is, it will be exactly half of the volume of sphere. Volume will be half of 4 upon 3 pi r cube. Okay, so it's 2 upon 3 pi r cube. That is the volume of this hemisphere. Now if we talk about the surface area of a hemisphere, further there will be two types of relationships. First of all, the curved surface area, that is the outer surface area, will be exactly half, okay, of the complete sphere. So curved surface area is half of 4 pi r square, that is 2 pi r square. Okay, now if we have to take the complete area of this hemisphere, then you can see this is the half of a sphere, and further we can see a circular shape over here. Suppose you can assume it to be a lid. So the area of this circular lid will be pi r square. So the total surface area will be 2 pi r square plus area of lid, that is pi r square. So it is 3 pi r square. So that is the total surface area of a hemisphere, and we have already calculated the volume. Okay, so these are the basic 3D shapes that we have discussed. Friends, we have discussed terminologies and formulae for various 2D and 3D shapes. Okay, now we can start solving the problems based on all these 2D and 3D shapes. And before we proceed with problem solving session, I would advise you to have a recap of all the previous sessions so you'll be comfortable in problem solving sessions. Apart from that, I'll be sharing tips and techniques with you while solving the problems. So let's start solving the problems now. Friends, one more important thing I would just like to share with you. We have discussed about Pythagoras theorem while we were discussing about triangles. Okay, so Pythagoras theorem is for any right angle triangle. Now what's that? I see a triangle over here that is with sides A, B and C. The side A, it is known as perpendicular. Okay, the side B, this is base, and this is side C, this is hypotenuse. Okay, there is a relationship among these three, that is B square is plus A square is equal to C square, that is base square plus perpendicular square is hypotenuse square. This is what is Pythagoras theorem. Okay, and the number that fulfill this condition are known as Pythagorean triplets. Okay, suppose I take an example of 3, 4, 5. So 3 square plus 4 square is 5 square. So we can say 3, 4 and 5 are Pythagorean triplets. Okay, there are other triplets also. I'll just take some of the basic triplets that you should keep in your mind, so you'll be able to save time in your examination. Okay, the other one is 5, 12 and 13. Here 5 square plus 12 square is 13 square. Okay, for then 8, 15 and 17. So 8 square plus 15 square is 17 square. So it is also a Pythagorean triplet. It is also a Pythagorean triplet. Okay, so these 3, 4 triplets that you should keep in your mind. Apart from that, the multiples of these triplets are also Pythagorean triplet. Now just see how. See 3, 4, 5. These are Pythagorean triplet, that is 5 square is equal to 3 square plus 4 square. Now a common multiple of these three, that is, suppose I double each of them, so it will be 6, 8 and 10. Now 6, 8 and 10, these three numbers will also form a Pythagorean triplet, that is 10 square is equal to 8 square plus 6 square. Then the triple of that, that is 9, 12 and 15, they are also in Pythagorean triplets. Okay, so a common multiple, that is 3x whole square plus 4x whole square is equal to 5x whole square. Okay, similarly 5, 12 and 13. So 5y whole square plus 12y whole square is equal to 13y whole square. Okay, so that thing you should keep in your mind. Now friends, let's take a very simple problem. The area of a rhombus is 28 centimeter square and one of its diagonal is 4 centimeter. We have to find out its area. Now first of all, just you might have revised the definition and formula for rhombus, I'm sure for that. So I have just drawn a diagram for the sake of conveniency. Otherwise, in examination time, it's actually not required. You can visualize the diagram. Okay. After some practice, I think you'll be able to visualize, right? Now, what is the formula for area of a rhombus? That is half d1 d2. That is half product of diagonals. Now, area we are given here is 28. Now, one of the diagonal is 4 centimeter. So, the other one we can find out. So, the length of the other diagonal is 14. Okay. Now, we got one diagonal and the second diagonal. Now this complete length is 14, this complete length is 4. Okay, I haven't drawn the figure to scale. So you just have to assume it that this length is 4 and this length is 14. Now, as I have discussed that the diagonals bisect each other and that too at right angle. So this is a right angle. Now the complete length is 4 centimeter. That means this length will be 2 and this complete length is 14 centimeter. That means this length will be 7. Okay, now we can find out the length of this. This is a right angle triangle in which this is perpendicular, this is base and this is hypotenuse. So we can definitely use Pythagoras theorem. So suppose this is S. So S square will be 2 square plus 7 square. So it's 53. Okay. Now we have to find out the perimeter. This is S square. So S will be root 53. Now we have to find out the perimeter of this rhombus. Now perimeter will be 4 times side. So length of one side is root 53. That means the perimeter will be 4 times root of 53. As simple as that. Okay, I hope you are clear. Now, this is a question based on trapezium. The area of a trapezium is 28 centimeter square and one of its parallel sides is 6 centimeter. If its altitude is 4 centimeter, then we have to find out the length of the other parallel side. Now, we have discussed the formula for area of trapezium. That is half sum of parallel sides into distance between them, or we can say altitude. Okay. Now here this and this, both of them are parallel sides. Suppose this is x, this is y, and this is altitude, that is 4 over here. Further, no need to draw the figure. Just for the sake of conveniency, initially I'll be drawing the figures for you. So it's 4. Now area is 28. I just put the value in this formula. Half sum of parallel sides. One of them is 6 and other we have to find out. So it's 6 plus y into altitude length is 4. I just put it over here. So 6 plus y is 40. That means y is 8. That means the length of the other parallel side is 8. Okay, just putting the value in the formula, nothing else. I hope you are getting me. Now, further this question is based on trapezium. The perimeter of a trapezium is 52 centimeter and its non-parallel sides are each equal to 10 centimeter and its altitude is 8 centimeter and we have to find out its area. Okay, now this is 10 centimeter, this is also 10 centimeter, altitude is 8 centimeter and we are given the perimeter, that is, suppose this length is x, then this length is y. That means x plus 10 plus y plus 10, that is 52. Okay, so x plus y is 52 minus 20, that is 32. Okay, now what is the area of the trapezium? That is half sum of parallel sides into distance between them or altitude. Okay, so it's 128 centimeter square, as simple as that. I hope you are clear. Now, the area of a parallelogram is 120 centimeter square and its altitude is 10 centimeter. What is the length of the base? As simple as that, base into altitude is area. Okay, so area divided by altitude will be base. So 120 by 10, that is 12. Okay, no need to go for any paperwork, no need to draw the diagram. Now let's see this question. The sides of a triangle are 3 centimeter, 5 centimeter and 4 centimeter, and we have to find its area. Now friends, if you can just have a recall, these three sides represent a Pythagorean triplet, that is 3, 4 and 5, that we have discussed just before some time, right? Now 3, 4, 5, if they are representing Pythagorean triplet, that means these three sides are forming a right angle triangle, and it's easy to find out the area of a right angle triangle. Okay, this will be base, this will be perpendicular, or we can say altitude, and this is hypotenuse. Okay, but we don't require it, we require only base and altitude. Now what is the formula for area? That is half base into altitude. Okay, so it's 6 centimeter square. Okay, if you can recall that these are Pythagorean triplet, then this problem will be very easy for you. Otherwise it will take long time to find out the area of this particular triangle, because in that case you have to use Heron's formula to find out the area. Okay, that is a lengthy process. Okay, our friends will be taking some basic problems in our next session also. After that we'll start taking some difficult ones. Okay, so just revise this session and the previous two sessions before coming to the next session, and revise all the concepts and formulae as well. Okay, bye bye, see you in the next session.